simultaneously alternating.
Wow, it's amazing. It's, you know, you look back on some of this tech, and it's like it's pretty astounding what they did back then.
Oh yeah, back in my day, that every manufacturer had their own operating system, and they were all proprietary.
Of course, they lock it in.
Down in my garage, I have one of the very early versions of their system that's sitting there. I might try to bring it up someday if I could find enough of the paper tape to
Paper tape.
So the interesting thing is, it's got 3 8K core stacks in it.
Oh my gosh! Wow, that's. Yeah, and now we complain that 4 gigabytes of RAM isn't enough, or 8 or whatever. Oh, there's our southern contingent.
Some had to wake up here, just so relaxed.
Jeez. He's out on the patio. Look at that.
You know, I'm going to apologize in advance here. If I'm having computer problems, it's because my laptop was getting a little bit too much sun today. So.
Oh, we feel sorry for your laptop.
Yeah.
It's a tough life, isn't it, Peter?
I tell you, I made a mistake there. I was going to put a background in today because I was down on the Gulf side there, out the beach there, dipping my toes into the Gulf of Mexico and stuff, and I thought I'd take a picture and use it as my background. But I was too relaxed this afternoon and forgot to do
it. Yeah, absolutely. It's tough. But, I spent a good part of the week going to the local Ministry of Telecommunications Information and something else or whatever. And if you notice on the screen, I've collected my Antigua call sign. So I am officially V21EG.
Oh,
so,
wow.
You know what? I think I'm just going to I'm going to kind of do a DXCC thing here, except it's for call signs. Every call sign except Canada. So, there must be an award for that. So,
Dave, you do have the option of kicking him out of the meeting.
Different call signs.
Anyway.
Nice. I used to be DA1SC a long time ago.
So I'm in a very noisy environment here. You can probably hear a lot of background noise. So I am going to actually duck out to a little more secluded area. I just wanted you to see the, nice port here. You can see it's not much to see because it's already dark here, but we're on Atlantic Standard Time and it's a little dark. But I wish I could show you some of the sights. But all you see is the what's called Memora Bay here in the beautiful island of Antigua, which is part of Antigua and Barbuda, which happens to be where we're taking a 2-hour ferry to tomorrow. So anyway, so here we are. So I hope me ducking out of the meeting does not stop the recording, but I did manage to successfully start that. And from memory, I don't think it stops when I exit the meeting. So if it does, well, Dave, I hope you connected your Dropbox account and all that. But anyway, all right. So I'll see you in a little bit, John.
Okay, go. Take care. Now, this is what Eric sent me earlier of what he was up to.
Yeah, that's right. I shaved my legs.
Should I send you guys a picture of what I've been up to today?
Nope.
You're sure?
No toilet shots.
It involved a proctologist and
I knew it.
Instrument.
Oh my God.
Anyway, why don't we before Eric? Oh, he's gone. Crap. Anyway, I thought let's do a quick QTH round table, and because I think we truly have a international meeting tonight. So why don't we just go around and just indicate your QTH where you're from. So I'll start. Eric obviously is in the south there. I'll start off. So it's Dave E3OI and Paris, Ontario. Dwayne?
Oh, KB4 QB, Dwayne down there near Atlanta, Georgia.
Frank?
Yes, there I'm V3FAO in the beautiful Sun Parlor of Canada, Amherstburg, Ontario.
And Kevin?
VA3KHH in the Italian capital of Ontario and Woodbridge.
And Michael?
Michael, VE3TKI, in northwest end of Mississauga in Ontario,
And
where it's just started to snow.
oh yeah, I haven't seen snow here yet. I know they were forecasting snow today, so. And Peter?
V3POA in sunny Tampa, Florida. And to be honest with you, I kind of forgot what cold was already.
And Hassan?
VE3HSC, and I'm in Southern Brampton.
Okay, and see who else I got. Wayne?
Yeah, VA3 NWH, and I'm in the northwest corner of Mississauga. If I moved a couple of blocks, I'd be in Milton or Oakville.
Okay, and I think the only person is Al.
Hello, everyone. Sorry
Yeah,
I'm late. I just stopped in. What's going on? Are we saying hello? Who are we
No,
saying
no,
hello to?
we're just because we've got several members outside of Canada. I thought we'll do a quick round table and just give our QTH.
Oh, okay. Well, I'm in Cooksville, Mississauga. So that's here, Ontario, and Dundas Street area, just outside of the GTA. So that's where I am, fairly close to the lake. And I guess like everybody, it's still cold here, but I see Peter down there with some cabana lights. And how's the weather down there, Peter?
It's chilly tonight, relatively speaking, but we're into the 80s, and I think we're upper 80s on the weekend.
The 80s, and it's chilly. I'm so sorry. Anyhow, I only have 9 people on my screen here. So
Yeah.
who else do we have here?
No, that's it. And I think you're the last one to check in. I
Okay.
think it's we hit a balmy like 3 degrees today or 2 degrees in Paris, Ontario. So I was outside in my t-shirt. Seriously.
Just because.
Yeah, just because.
It's coming. Can't wait.
Yeah, another month. Anyway, let's start going here. I think we've got a couple of presentations, discussions, not really formal presentations. But we've got Wayne up on deck, and then Hassan. And then I thought, if there's time permitting, we had a conversation a couple of weeks ago about potential kits or projects, club projects or club kits we could work on, because I think with the pandemic at the tail end, and we'll be able to start in-person meetings and maybe get back to doing buildathons, and it'd be good to start thinking about what some good projects are that we could work on. So maybe we could close out with that. But Wayne, are you ready to go?
Mm-hmm.
You're going to talk about your magnet?
Sure. Okay, gotta remember how to do this. Share screen. Oh yes, it's the button in the chat. There it is. Share screen, I'll do that. Give it a second while I figure out how to do this. Okay, so what I'm going to talk about is an antenna that I just purchased about, I guess it must be 3 weeks ago now. It's an active loop, and I brought it up on the screen. Hopefully you can see that. Everybody can see that?
Yeah, we can see it.
Okay,
Yep,
cool.
yep, it's good, Wayne.
So this is an active loop. It basically covers the HF and the medium wave bands. And I have been looking for a solution to the kind of noise environment that I live in here. So well, I see a lot of noise, which I believe is external to my house, in my and also local. And I was thinking about putting up a phasing kind of a technology. And so for that, you need two sets of antennas, one which would be your main antenna, another would be used to help you phase out the noise on the receive side. So a magnetic loop antenna is often suggested because it doesn't take up any space at all. And while I was doing some research on this, I found out about this particular thing I brought up on screen, the MLA 30 and 30 plus. You can see it's on sale for US $27 at AliExpress. I think it goes for around the $25 price point plus shipping. I came in close to that. And so basically, I was just talking a little bit about what I've done with it. And I don't really intend to go outside until it gets warm enough. So my antenna is running in my basement. And we use an SDR. I have an SDR play, and I use that to do basically the graphics allow me to see what the spectrum looks like, and allows me to see what the noise floor is and where it is and that sort of stuff. So I got a couple of pictures of that to show you guys, and I will do that in a moment. Oh, yeah, I should stay on this particular page before I bring this up because it's got better graphics. So this is what you get. Okay, so you get, this is the what the antenna wire hangs onto. So that's the actual amplifier sitting out in your antenna. This wrapped up little guy will open out to be about a 25, 26 diameter, inch diameter loop. The cable, I think, is about 10 meters long. That is an amplifier. It takes in a 5 volt, USB cable, and it outputs 12 volt DC to power this through the coax, and you connect your the other end of the antenna to the receiver, so it takes care of not providing DC into your receiver. That's basically all you get. You can see that a couple of excellent little screws here to go with it to screw it on. This is the normal configuration, right? So you can't really see it. There's wing nuts here, and the wire connects to the wing nuts, and you usually strap it onto a pole. That'd be how it's done. All right. So I snapped a couple of pictures, and I just want to show you what I got. Close up of what you actually get is, here's the power supply, 5 volts in, 12 volts out, and the antenna comes out that middle one here. This is the magic stuff. One of the reasons I got this was I thought, for 25 bucks, that's a cheap antenna. I could probably make one of the hobbyist versions of this that are available on the internet, but I thought I would just basically spend the money and buy one first and see how it performs before I get into that. If you look at the case, it looks maybe a little bit not weatherproof for Canada. That's how I thought it would. So what I did is I just unscrewed this thing and took a look, and here's what you got. Looks like they made a manful attempt to kind of pot it nice. So, you've got what might be hot glue down at the bottom to protect where the coax is coming in. You've got this entire case enclosed in some kind of dark plastic that's supposed to protect it or maybe hide the details, I don't know. Yet you've got this trim pot sitting out in the open. So I suppose, by the way, it's oriented, the vertical is probably how it would hang on the antenna. So if you think about this thing getting wet, the water can come right up to about here before you have to worry. So it's probably okay. I might want to seal the outside surface a bit better than it is, but this might actually work outside as an all temperature type of antenna. So I might just go with it. What I did was, I have an SDR plate, and the software you're looking at is SDR Uno. And what I did was I tried my external antenna, and this antenna is actually sitting in my basement. Originally, it was in the worst possible orientation. I forgot to, actually, I didn't forget, I just didn't remember the right way to orient it to get the maximum signal strength. So originally, I had a slide here showing it at its null point compared to the station I'm showing you is on. So at the bottom, this is my external antenna. I have a very low fan dipole, so it fits in my backyard. I was seeing the number, which is right here, vary a lot, of course, because of ambient conditions. But I was seeing a range of, I think, just under 20 to about 30 or so dB signal to noise ratio. And the floor is basically at 120 something, okay? If I put the indoor antenna on here, which has got an amplifier on it, I see the noise floor jump up, but so does the signal, which is interesting to me because I really don't know antennas. I don't understand them very well. But I would reckon that because the noise floor ramped up about 25 dB, that's probably how much it's amplifying the entire segment. And the signal to noise ratio is fairly close, comparable. This is an accident. They look like they're identical in this particular case, but generally the indoor antenna, the antenna as it's performing inside my house, was about, I think it's about like 5 dB lower when it's oriented for the maximum signal. So it might do quite well, but very comparable, I think, outside, which means to me that it probably worked very well as a phasing antenna if I can get it, shall we say, far enough from my transmitter that I don't blow it up. And that was basically what I wanted to show you. It's a really good antenna. If you have an SDR, it's very peppy and surprisingly, well, from my perspective, it's surprisingly quiet. On my SDR, can break how high that noise floor went. Just the software takes care of it. So I'm going to stop there and pause. And if you have any questions,
it's Michael V3TKI.
Mm-hmm.
What's the power rating of it? Is it a QRP antenna or what?
It is a receive-only antenna. Sorry, I should have started with that. It's called an active loop. So it's got an amplifier right at the head of the antenna.
Oh, of course, that's right. Okay.
Right? So you know, we have little instructions like, please do not power this thing up.
Yeah.
As it'll make smoke. But its purpose, you know, is it's either receive antenna or, as in my case, it's an auxiliary antenna to help me improve the main antenna's reception. Actually, you can see on the screen, this particular band of noise, you can see as verticals. You can see a lot of vertical stripes. I do from time to time on my SDR, do see things on the outdoor antenna that are kind of evenly spaced. It's like somebody's having running a bloater near my house, that kind of stuff. I see a lot of that at different times of day. I know this is not all coming from inside my house, although this particular graph might be because of the way I posed it just to get a good image. Because I've done the normal noise checks. I've turned off everything in my house, pulled out all the wall warts, turned everything off but the actual computer itself, and the antenna was coming from outside. You know, and I have the usual number of ferrites wrapped around everything I can get my hands on to see if I can quiet things down. So I do see in my location a lot of noise, which I interpret as being coming from outdoors, and it varies from time to time in the day. I do not know if it's local or far, but I anticipate that I find that it's local enough for a phasing technique to actually help me.
And Wayne,
go ahead.
Peter's got his hand up.
Sorry, thank you, Peter.
Yeah, Wayne, yesterday I think it was, or the day before, I read a report on this antenna comparing to the more expensive loops. I can't remember which ones they were off the top of my head, but they were in the $300-400 range, if I recall correctly. And this antenna compared not as good, but awfully darn close to what the more expensive ones were doing. And as this guy concluded, you know, for the price of it, why would you spend that extra money on the other ones unless you really are after that last little tiny bit, which probably most aren't. So this antenna really got a peer review, you know, compared favorably to the more expensive ones.
I've seen the same, and I totally agree with it. I mean, I'm getting almost the same reception indoors as I'm getting outdoors. Now, obviously, how it works is I chose an AM station because you can see a giant, you know, spike where the carrier wave is. So we can see what the signal to noise ratio is a little bit easier here. Basically, SDR can hear can resolve SSB down to about, say, I think around 5 to 6 dB above the noise floor. And you can hear CW at the noise floor, maybe below it. So what I'm saying is when I looked at a signal, I could generally, what signals I could hear on my outdoor antenna, most of the time I could hear them on my this indoor antenna while I was testing it. And sometimes it got to the point where it was easy to resolve, I would say, on the outdoor antenna, but a little hard to hear on the indoor antenna, but not that far. And so I'm calling that about a 5 dB difference indoors compared to outdoors. I do not know what it'll look like when I take it outdoors. It'll be pretty good. Now, my outdoor antenna is not that great. It's very low in the ground. I don't have it raised up very high. And it's a very narrow V, so it's pointing to, as I understand the physics, which I don't really understand, it's essentially concentrating in a north-south direction. So I hear a lot of US stations due south. I don't hear anything east-west to speak of. And I've got it configured. This antenna, because it's a loop, you can actually turn it on its axes and mellow north-south if you choose to. Which I think is probably that's probably the way you do it if you're trying to close out an ambient noise. Maybe I'm not sure, but if you have a directional antenna pointing at 90 degrees from your direction, another directional antenna, it might be more likely to capture random noise that's around your neighborhood. Well, of course, I guess if it's actually in your next door neighbors, you probably want it pointing so that it got the same kind of noise, I guess. But when it gets warm enough for me to take it outdoors, we'll know.
So Wayne, one of the interesting things I noticed between the two plots there is that I don't think it's an antenna. I think it's your SDR receiver. If you look at 15.1, it starts to roll off. And it looks as if the lower for your fan dipole, it's also rolling off too, because the noise floor drops below the horizontal line. So do you know what's going on there?
Yeah, I'm pretty sure it's the software, not the SDR. What you're looking at is the way I'm showing you a very wide window. Essentially, when you're focusing in, it's on the center of the page that you care about. So as it goes out towards the edges, it does drop off on all views on the SDR. But if I were to, I could go to 15.1, it would pop up as high as it is in the center. It's just the way the software tends to work on the wider views.
What's the filter? I guess it's the digital filter they're using. That's where the filter starts to roll off.
Potentially, I'm not sure how it actually works internally in terms of what you're looking at. I don't know how wide that filter really is compared to the view that the software is giving me.
Because it's.
Go ahead.
No, because I was going to say it's so smooth coming down. It's like a skirt of a filter. It's coming down so smooth that it looks very much like something a filter would do.
I think you're probably right there, because if I were to tune the tuner down to 1500, it would show the same shape, but where it starts to slope at 1500, it would be down 800 kilohertz to the left. You know what I'm saying? And if I were to narrow it in so that, yeah, I've hidden it here. Let me just see if I can fix that for a second here. I'm gonna just drag this guy out of the way here a bit.
And then Wayne, as you're doing that, I've got another question.
Yep.
You could think as you're doing this. Yeah, you could. Yeah, there you go. There's the roll off on the high side. Mm-hmm. Is that how do you tune this? So is there any tuning? So for example, if you want to go to say 80 meters, is there any tuning you have to do, or does it auto tune at that frequency?
As a receiver, no, you don't tune. I mean, obviously, if you're asking how do I, move the frequency dial, there's all kinds of things to do. One is I can click on the 1577 here and scroll, as it were. but it doesn't need to be tuned. It's a receiver. Okay, so you really are. The deal with receivers is they're much more sensitive than they may have to be, I guess. So tuning doesn't seem to be much of an issue on the receiving side.
So
More initial transmitting.
your receive antenna doesn't have to be resonant?
Nope. No, this is not resonant on all the frequencies that I can listen to.
Yeah, and that's what I was getting at, because I know some of the mag loops, they've got a tunable capacitor in that
Well,
box.
that's a good point. This does not have a capacitor. In fact, it's the style of this approach is they're using a broadband amplifier, which was in that black goo that I showed you earlier, that is basically covering the entire HF spectrum, and that's why the noise floor is so high. It's actually, I'll have to tell you, it's going to be horizontal straight across, all the way across the entire band. That roll off, as you're saying, is some kind of filter effect with respect to the view that we're looking at. But I mean, if I were to roll this view across a megahertz, it'll still be that high. It is, in fact, inherent in the amplifier. Where the amplifier rolls off, I haven't played around too much. I've taken it down to the AM broadcast band, but I haven't worked to see how high it goes past 30 megahertz. That's its upper limit officially. I don't know where it kicks out.
Yeah, that's pretty cool. I think Kevin has got his hand up.
Sure, Kevin.
Yeah, I just wanted to come. You were talking about the not tuning it and such. I should have talked to you, Wayne. It's like because I was going to suggest a project that I came across in QST, and it's basically a broadband amplifier with a very high input impedance, but you can have it sit on your regular antenna, and it's protected up to 100 watts. So in other words, you can hang your SDR on it. You don't care what happens, and you're not going to blow up your SDR radio because it protects it. And so it exactly ties in with what you're saying. And this one also, it doesn't care about tuning. It's a very, very high input impedance, right? So it doesn't need to be matched because the antenna doesn't match anyway across most of the frequencies, right? So anyway, it just kind of tied in. If we want to talk about it later, I've just got a PDF. It was a project out of QST a few years ago.
Sounds cool.
And anyway, so that's what you're saying. Yeah, this one doesn't need any tuning. It sits there. It's like, because I've always wanted to have like an SDR on field day or whatever. You can sit there and scan across the bands, but you don't want to blow the thing up, right? and this prevents that from happening. It keeps the magic smoke in. Anyway, sorry.
It's not connected all the time because of that. Like it just can't.
Yeah. This just blanks out when a transmitter comes on your antenna. It clamps it, prevents any energy from getting through to your SDR, and away you go. And then
that's interesting because I had a project like that in mind. There's lots of software switches for protecting CDR.
So anyway, sorry. Continue on.
Not to worry. The reason I was fussing around is this is the software. It has a zoom switch, which I couldn't see because I had it covered up. If you click on this, basically it zooms in, and by zooming in, you're looking at a narrow frequency, if I remember correctly, because you don't ever pay attention to stuff. It's rolling off at the edge of the zoom as well. It's just the way the software is, as Dave was saying, is filtering the input. This is SDR Uno, which was developed by the makers of the SDR Play series. These SDRs generally work on pretty much anything that's open source anyways. There's lots of different softwares you can choose to use. Okay, that was, I guess I don't need to show you some more. That was me. Stop sharing. Anyways, as Peter said, this is you got a few bucks that you don't have committed to anything. This is a nice buy. So I'd say.
That's pretty cool, Wayne. Thanks a lot for doing that. Any other questions? Oh, I see one hand going up, and who's got their hand?
No, it's me. I took it back. I was just going to make a quick comment. And of course, they've got that gunk all over it, so it'll be a little bit tough to reverse engineer. But
That might have been on purpose, yes. Yes. So I thought, one reason for having that is, of course, they're protecting it from the environment, but then why would you have an open turn pot? I guess it's because they trimmed it before they were done, but, they could have covered it up. But I think it's, and there's lots of public source, there's lots of examples of projects that are homebrew like this. So you can do it at home if you choose to.
Yeah, it's kind of interesting, Wayne, that it was sealed, because normally I think any outdoor box, don't you have to drill a hole to let the water come out at the bottom?
I should hope so. I mean,
Yeah,
there is a hole there, but it's sealed.
No, but it was sealed because the coax, they looked as if the whole box was like completely sealed. And normally, most boxes, your windows, everything you've got, it's got a drain hole at the bottom to let water drain out, right?
Yeah, could be the case. I mean, I don't know who manufactures this, by the way. This might be, in fact, a clone I bought. I don't really know if the brand is made in China or if I bought it from China, it was made somewhere else. But, just looking at it, it wasn't made for, I think, the environment that we're in. And I was surprised at finding it sort of sealed on the inside. Certainly, the seal of the cover case, it's not, I don't know if you saw it, it's never a real ridge to seat the cover in. So that basically would need to be treated anyways. It's not, in my mind, it can't be watertight as it is. And you have to drill a hole or pop that, whatever that white glue was, off the coax.
Okay, very good. I think, Michael, you had your hands up and then went down, did you?
Just a comment. I don't know, probably almost 10 years ago now, some of us at the Mississauga Club built the SDR Ensemble 3, which is a soft rock type SDR, and we did it over a period of a few weeks, and it's a multi-band thing with switching through ICs, and it does 80 through 10, I think it was. It was kind of an interesting project anyway, so who knows, it might be something worth looking at for the homebrew group. Just a thought. I did go have a look to see if on the web if I could find the Ensemble 3, which is what it was, and it not easy to find, so I don't know whether it's still available or not. But it was kind of an interesting project anyway. Might be something to think about.
These are really good suggestions. I'm just taking some notes here about some for future homebrew projects. Okay, any other questions or comments? Okay, Hassan, you're on deck. I think you're going to talk to us about the gunplexer, and you're going to do a demo, and you're going to do an electro boom style where you're going to blow something up.
In reverse order. So all I can do is talk today. I tried to set up the demo, and just now when I was turning it on, testing it, it started clicking. I heard this ticking sound. So I turned off all my power supplies and everything, and it was powered by battery, and it was still there. So somehow RF was causing something to kind of click, like really high, like fast clicking and ticking. And I don't even know what was ticking. So the RF around the gunplexer was causing something to go haywire, and I just turned it off right away. I don't want to blow up all my test equipment. So I don't have a demo for you. I'm sorry.
Well, maybe you could start from scratch one and just, what is a gunplexer? Because I think it's got something to do with microwaves, right?
Yes, I can show you my setup if you want to see it.
Sure.
All right. Give me 1 sec. I'll go back down. So a gunplexer is a really simple microwave device. It's what's that sound? Okay. It's shockingly simple. It's basically a gun diode and hooked up inside a waveguide. and all you do is apply DC power to it, and it starts to kind of oscillate. And then there's one more wire for the, the input signal, and it magically modulates it. And the receiving device is symmetrical, it's identical. And for that, again, you just hook up to the wire, and magically it demodulates everything. So with a minimum of parts, you can actually have a working microwave link at 10 gigahertz. Let me turn on the camera. See how to...
Nice ceiling.
Thank you. How do I swap cameras? How do you flip the camera around in Jitsi?
I have no idea. Are you using a phone?
Yeah.
Well, I think it's a button on your phone you got for going for a selfie or regular.
Hassan, can you hear me?
Yes, I can hear you.
Yeah. So on your camera icon on the bottom, there's a little up caret. If you click on that, you can choose the camera there.
Oh, this is a phone app. It doesn't have the caret. Let's do it upside down. Can you guys see this?
Yep,
Okay.
that's working.
All right, so there's two modules here. This is one of them, and that's the other one. So I've got some janky wires hooked up here, and I've got it hooked up to the scope and to the test circuit, and this is the battery for the receiver. I use the battery because there's less noise. And so plus 12 coming in, it goes straight onto the, one to ground, one to the white wire, and then this wire is hooked up to a function generator. And on the other end, it just went straight to the scope or a voltmeter. So it was working, I swear it. I could put my hand in front of it. I could interrupt the signal. I could measure different things. I could turn it, and it would actually detect the change. But the problem is what I just described. I mean, at some point, the receiver was hooked up, and it was causing something to tick in this general area. Something was kind of, maybe I can show you. I'll hook it up. Do you guys hear it? Well, it's very hard. It's very faint.
Yeah, a little bit.
You've got, Hassan, you've got all your probes sitting on top of that screwdriver there.
That's okay. That's the ground signal. That's no worries.
Yeah.
That's just the ground. It's a really bad setup. This was, I should actually do this properly, I think, because it's actually mildly dangerous. So
what type of modulation? Like, is there any limitations on the how you modulate the microwave frequency?
No, just straight analog. The bandwidth, I think, I'm not sure. These are set. The way it works is there are two modules, and they're offset by like 500 megahertz, or maybe it's 50, but they're slightly offset, and so they beat the other one down into the right range. So, I mean, that's how you can get like full duplex communication. So, I mean, essentially you get a signal out, and I think you just use AM detection on it, and that's how it works.
Yeah, because I'm kind of curious to know how you would, what type of modulation you could do, whether it's like a off-on keying, or you could put in like any kind of analog. Could you put in audio, or do you have to put in higher frequency in to have it modulated?
I think you can do on-off keying, so you can do digital, you can do analog. I think you can do like straight voice, because it's basically like an AM radio link.
So it's got no limitations in terms of the frequency you can modulate the diode at.
No, it's got a really wide bandwidth. It's just a simple mixer and a modulator. So pure analog bandwidth.
Yeah, I can't believe it's that simple. That's incredible. That's pretty cool.
I know, it absolutely blows my mind. but it's real. So they build radar detector guns out of this thing. So what happens is, I think the cavity, the waveguide itself is the resonator. So you don't need a capacitor, inductor, transistor, and all that. The gun diode is the active device. So you bias it in its negative resistance region. And at that point, it's kind of like, I mean, to take a physical analog, I suppose it's like well, I mean, what's it like? It's like if it's almost like an oboe reed or something. You blow on it, and you blow DC air on it, just a steady stream of air, and it just vibrates. And that's the way to think about it. But it vibrates at 10 gigahertz. And then the energy is it's right inside a waveguide, like a cavity, like a square, a cubical rectangular box made of metal. And the energy is in there, and then the outside of there's a hole in one end, and it just comes out that end.
And from what I remember back in my days for waveguides, it has to be a certain size so you get nulls at the edges. You have to have a certain wavelength inside, right? It has to be a certain size, right?
It does, although in this case, the way to think about it is, you make it a certain size. You drive it, and it'll oscillate at whatever size it already is.
Oh, really?
Yeah. So I mean, like, okay. So what you're describing is, if you're sending in a sine wave of 10 whatever gigahertz, you have to match it to the waveguide dimensions. In this case, I'm not generating AC at all. I just use a DC input. So it oscillates at whatever size the waveguide is cut to. Think of it as a whistle. What do you need to blow a whistle? You just need a steady stream of air, and you get AC out the other end. There's no oscillator, like there's no active circuitry or anything. It's all passive.
So it's like an acoustic guitar. Because you play the note, and that note resonates inside the body of the guitar.
Yeah, but guitars are plucked. You put an impulse there. So that's a different phenomenon. This is like, you have a steady stream of air, and you can get continuous output. Guitars do not give you continuous audio.
Right. I think Wayne's got a question. He put his hand up. Wayne? Wayne, you're on mute.
Yeah, it was so well worded before I didn't actually say anything. Okay, so Hassan, is it possible that the wavelength, the waves or the frequencies are actually coming back through your DC input? So that's what's causing your, you know what I mean? Like if it's resonating inside the box and you're just applying DC, would any of the super high frequency be coming back through your DC line and causing the?
It's possible. It was being driven by a battery though, and I don't think it should have had any negative effects. And
okay.
And it was working before, so that's what's puzzling.
Right.
Sorry to have to provide the first no-show ever in PARC history, but I actually hadn't gotten a confirmation email back, so I didn't prepare yesterday for it. So my sincere apologies.
No, but it's a good discussion. I think Michael had a thing. Michael,
I have a question. Is the distance from the waveguide that was sort of at the front of your desk to the horn in the back, is that arbitrary? And that was one question. And the other thing is, I presume if you turn the source, which is right in front of the camera, to the right or to the left, it would miss the horn in the back and you wouldn't get any signal. Is that right?
That's correct. So I've moved it across. It's only like the signal's only 10 milliwatts, so it's only good for going like across the room or something. I moved it back. It seems to work over some distance. I can't remember exactly how far it was. And if you turn it, you can actually see the nulls, right?
Very neat.
Yeah. And apparently it's polarized as well. So if you rotate it 90 degrees, you get no signal either. So it's got that feature.
And where do you get these things? Like
I got
sale or
them.
what?
No, I got them on eBay. And ironically, the guy who was selling them lives in Mississauga. And he's,
Oh, I remember that. You told us that.
yeah. And eBay prohibits you from actually soliciting personal information from buyers or trying to meet them in a parking lot or something. So I couldn't even ask him who he was or, get some tips from him. But someone's out there who in North Mississauga, probably 10 minutes away from my house, who apparently has a bunch of these things.
And I think Hassan Peter's got his hand up.
Okay.
Yeah, Hassan, I'd like to request that you put the camera on and you stand in front of it, because after you've been playing around for a couple of weeks with 10 gigahertz, I'd like to see if you have any hair left.
Oh, that's not my problem. I have too much hair. You don't want to see my hair. I'm not having a good hair day today. All right, there we go. Can you see me?
Can you walk on water?
Well, that's the look I'm going for. But you know what? My basement is leaking. One of the pipes is leaking, going to the kitchen. So yeah, I guess the water walks on me.
So he is walking on water. Very funny.
Yes, I was literally.
Yeah, I just did a quick Google on gun diode, and it came up on Banggood, but they don't have any. It says it's got gun diode, but I think it's just cluing in on diode. And how is it spelled? G-U-N-N or G-U-N?
G-U-N-N.
Yeah, I did that. It said Banggood has them, but they don't.
Oh, you know why? Because a lot of them come from Russia. And so since they come from Russia,
everything.
Yeah, he can't buy them right now.
Yeah, Pasternak has them. But you're going to pay a sweet penny for, because that's more, I guess, commercial grade stuff.
Mm-hmm. Yeah, these things have ridiculous bandwidth, and I can't wait to take it outside and experiment with it. But I think I should probably wire it up properly to, put proper connectors on there rather than alligator clips. I think that'll make it a lot more stable. And I probably will. I was going to ask you guys, what type of detector should I put on it? I was just using a voltmeter, and it measures 0 to 10 millivolts. But I should probably build a proper amplifier at this point, like an op amp.
To get the demodulated signal.
Yeah.
Yeah, it's gonna. I don't know what the specs are, but you may need some kind of amplifier, some sort of filter, maybe because it might pick up extraneous stuff.
Right. So all that stuff, I guess that's a whole project in and of itself.
What's the frequency range that it's going at? Is there anything else in the house? You've got Wi-Fi or anything else at that frequency?
Nothing at 10 gigahertz. And I know it's coming from this thing because when I disconnect the power, the ticking goes away.
No, I meant in terms of noise that you would get in the receiver, right?
Well, the funny thing is I hooked it up to my oscilloscope, and I can't get a clean signal, but my voltmeter will actually register it properly, like 10 millivolts. And the other thing is like 0. So there's something funny going on there. I don't know what exactly it is.
Is your Peter and Michael's got their hands up, but is your scope set to AC or DC coupling?
I tried everything.
Okay, so let's go over. I think Michael had his hand up first. Michael, you want to go?
So the source, it's the gun diode, right? So you give it DC or something?
Yeah,
or do you give it something modulated or what?
So there's two gun plexers. Both of them have gun diodes. One is the receiver, one is a transmitter. For the transmitter, I tried a couple of things. I just tried straight on-off keying. So just, power up, power down. And I was just trying to see if, and it does detect it. It does detect that there's power on the output and there's nothing on the input, nothing when it's off. Then I put in a low frequency, square wave, and I can see it going up and down, up and down. So that's what I've been testing so far. I have not tested like sine wave modulation or audio, voice, or anything like that yet.
And the receive end is just another gun diode in the horn.
That's right.
Receives, and it detects the signal somehow and creates a DC output voltage, I guess.
Yeah, it mixes it down. So if there's a carrier, it's kind of like AM. If there's a carrier, you've got thing, and I guess if when you modulate the carrier, when you modulate the input, it mixes the input. Well, there's a carrier frequency, and then it just mixes it to that. So it's just like an AM receiver and transmitter.
Okay. Yeah. Thanks.
Sure. Okay, and then Peter, you got your hand up?
Yeah, Hassan, you mentioned that you tried to look at the signal with your scope. Now, I know you out-fancied us and bought a fancy-dancy scope there last year, but it's going to see a 10 gigahertz signal?
No, it was I hooked it on the mixer output. So.
Oh, okay. All right.
Yeah, I wish I don't have access to a fast scope anymore, so I can't even debug this thing.
Yeah, there's probably a backyard way of doing it.
Yeah, I think we've been spoiled by oscilloscopes, so now we have to basically rediscover all the techniques that the early amateurs used when they didn't have test equipment like that.
But is there, Hassan, if it's 10 milliwatts, you said, right? And you're using a battery, a 9-volt battery, why would you be worried about the dangers of it?
Why would I be worried about the dangers of it? I'm more worried about blowing the gun diode on this thing.
Okay, got it. No, I thought you were worried that you're going to lose your hair, or
he's got lots of hair to lose.
Yeah, no, I'm worried about losing my test equipment as well. Yeah. Short the scope or something.
I thought you were saying testicles.
I never thought of that. It is at the right height.
Yeah, it's about the right height, so you got to be careful there. But that's what I was asking, because at 10 milliwatts, I think you'd have to have it touching you to have it do any damage, right? Because what's a cell phone putting out?
200 milliwatts, 100.
Yeah. So 10, I don't think you have to worry about anything. But even still, if you put your test equipment to it, could it damage it at 10 millivolts coming in?
I don't know. You're right. It probably will not damage it at all.
And I guess one thing you could do is just put a capacitor to couple it, so you're only getting the changes. You're not getting any DC level, right? Because I don't think you're going to get a spike coming out of the receiver that's going to be like 200 volts or 2000 volts, right?
That's right. I guess the thing is, though, I don't want to blow the gun diodes themselves, because apparently they're static sensitive devices and all kinds of stuff can happen. So that's what I'm more afraid of. I should go step by step, check all the voltages, check connections, check everything, and then go, make sure the connections are solid. I think that's probably the real issue. I think this janky setup I have is basically needs to be kind of hardened.
And also too, Hassan, Occam's razor, is your battery dead?
That is a very good point, but it's a brand new battery.
Okay.
In fact, that's probably why it's not working. The old battery I used was, 8 volts, or it was really drained. So this is a brand new battery.
Yeah, and I think Peter's got his hand up again.
Yeah, Hassan, you've mentioned a couple times about your the way you've got it all hooked up in your bench. I mean, how many times? I mean, I don't know how many times I had to learn the lesson of where you got wires all over the place between just the interconnecting between the different boards and all the different probes you put in things, and you wonder why. Sometimes it works, sometimes it doesn't, and why did it work yesterday and not today? And erratic readings, and then finally you just do it properly, and things settle down and they work much better. So you're probably wise to do that. It's interesting when you mentioned about the battery. I know you just said you had a live battery, but I seem to recall, and I can't remember what device it was, but I started hearing a tick, 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 tick sound when the battery was going dead.
Really?
Yeah. Obviously not with a gun diode, but I'm just saying I have seen that kind of phenomenon before, so you never know. Take your voltmeter out and measure it.
Yeah, that's an interesting point. Thank you.
Yeah, even that's a good point, Peter. Even maybe measuring the current coming out of the battery, because then you could see if it's got the current's too high, because then you could turn it off. Or I noticed one of the things there, Hassan, as you were showing your shack, you got the exact same power supply I've got. Is that the what's it called? The
Banggood Special 0 to 60 volts or whatever.
Yeah, the Kai Suites.
Uh-huh.
Is it the Kai Suite power supply you got? It's the black power supply?
It's black. Let me check the name.
Yeah, it's exactly the same as mine. My brand is Kai Suite, and I think I got mine off of Amazon. But it's coming from the same place. It's coming from China.
Yeah, it's the same one. Kai Heats, Kai Wheats or something.
Yeah, it's the same one. Do you? Sorry, Eric's got his hand up. Let me monopolize Hassan for a second before I turn it over to Eric. Are you finding that you're getting noise on that power supply? Because I've looked at some of the reviews for that power supply, and they were saying that it's got quite a bit of common mode noise because it's not properly grounded to the chassis ground.
Uh-huh.
They don't have enough capacitors to take out the noise, because I think there's a what's the inductor, a common mode inductor, and then before the common mode inductor you're supposed to have it a shunt to the chassis ground.
Uh-huh. Okay.
And so they were talking about that, and there's a couple of videos where guys went in and they put in like some poly capacitors, like 10 microfarads and a combination of 10 and 1 or something like that, and it cut the common mode noise down tremendously.
Oh, that's interesting. I don't know what common mode noise is, but it's
if you think what they were doing, they were just taking the scope and taking, like, for example, your ground lead or the test lead, and just connecting it directly to one terminal.
Uh-huh.
Whatever you do not connect your both ground and live to your scope, because you will blow your scope.
Say what?
Yes, in that power supply, you never connect it directly, like your ground and active to the terminals, because it's your scope's ground, chassis ground, is connected to the chassis ground of that power supply, and so it may use if there's a fault, it may use your scope probe to return as the return.
So what you're saying is I can't, like, normally what I would do is hook up scope ground to the power supply ground, scope probe to the V out.
Yeah, you got to be really, really careful, because if there's a fault, right? Because if there's a fault inside the power supply, it goes to the safety ground, to the chassis ground, right?
Okay.
But all of a sudden, you've got your chassis ground now connected to the ground of the floating ground, so it could use that as a return path, right?
Understood. Okay.
Yeah.
Right.
So, and I think Peter probably understands that a little bit more. He's got his hand up. But let me turn it over to Eric. He's got his hand up, and then I'll turn it over to Peter. Eric, you want to go ahead?
Yeah, just two.
Well, yeah, I was
simple
just going to make a
questions.
comment. I think that.
Oh, Peter, you want to go, Peter?
Oh, okay. No, I was just going to say a comment. Like I think Dave, you referred to what I think is called a floating measurement. You know, where you're taking your ground and you don't want to. The ground of your scope I'm referring to, you don't want to put it to anywhere on your circuit other than the ground, because if you go to make a measurement otherwise where your ground is going somewhere like into the circuit, what's that term? I forget. Floating measurement or something like that. You would end up shorting out your circuit. That's why you need the active probe if you want to make differential. That's the term. If you want to make the differential measurements.
Right.
You need the active probe because scope ground is the same ground as your power line, which means if you do a differential measurement, you'll blow the circuit.
That's right. And so Dave Jones is that power supply's got three.
Recording is on.
It's got a chassis ground, and then it's got like the floating ground, the actual not really ground return, right?
Right.
And so you're supposed to shunt that if you're going to be making measurements, right? But Peter's right. If you take that ground pin and you don't connect it to the right place, all of a sudden your return path is going through your scope.
So I think the rule is never connect your scope ground to anything in the circuit. Just don't do that. Make sure you don't do that. It's okay to put the positive terminal to something in the circuit, obviously, but you never connect the scope ground internally across, say, a resistor inside the circuit or something, because you're going to blow it. That's what Dave says.
Right. That's right. Exactly. The ground in your scope for a straight measurement is only going to be on a ground. If you need to make a differential measurement, then you need to use an act. Otherwise, you'll see. Well,
or what you do,
the smoke out.
Or what you do is you use an isolation transformer, which works on the scope, which apparently works.
Interesting.
I think I'll build a differential probe before I go and buy an isolation transformer. But good point.
Yeah, after watching that Dave Jones video, now I'm paranoid about using my scope. And Dwayne, you got your hand up?
Yeah, normally for if you have a 2-channel scope, what you can usually do is connect your probes to the actual ground on the circuit, and the floating point device that you're trying to measure across. You put one probe on one side, one on the other side, and you can set up the scope for differential mode.
Good point. Yeah, haven't tried it, but
Yep, that's right. The way I think about it is the scope input is a high impedance input. The ground is a low impedance input. So don't connect it to anything that can put a lot of current into the scope.
Yeah, exactly. And that's what Dave Jones was saying, because if there's any kind of fault, it's going to go through. He said chances are it won't damage your scope, but it'll certainly blow up the probe itself.
Yeah, it'll do, well, all kinds of things can happen.
Or your circuit.
Well, yeah, your circuit can also blow if something's connected to a low impedance. The ground is a soft input, so if it's a lot of current, it could blow the circuit too.
Paranoia is setting in. It's and I'm also paranoid enough about my spectrum analyzer not to worry about this too. Thanks.
Yeah.
Use a battery from now on. Everything's connected to a battery, right?
Well, no.
Give up the hobby.
Basically,
sell everything.
Throw away your scope probes and just use coax and connect it to specially designed test points. That will never go wrong. Like I've seen like circuits or test. I was walking around an old lab today at work, and they had a whole junk bin there, and all the circuits they have got coax FMC connectors and coax, like mini coax connectors. and they just plug them into that. They rarely ever probe stuff on the board. It's just too error prone.
You know, Peter, remember way back when we started talking about getting guest speakers? One of the guest speakers that was willing to come and do a presentation to us was Jason at Siglant, and he would be a good guy to get on here to do a little presentation about scopes and essays and stuff, and we could really put the screws to him in terms of asking him questions.
You going to talk to him at Dayton this year?
Yeah, I could ask him, certainly. I can, if he's there, and if I go, yeah, I can ask him. Oh, by the way, do you see that?
No, I can see the real hams. Can't see anything else.
It says real hams went to Hera.
Okay.
What's Hera?
Hera Arena. That was where the original Hamvention was, and that place was horrible. Just
you still wearing that T-shirt? You were wearing it last month. Haven't you washed it yet?
No, I haven't taken it off. I sleep with it. No, Eric Bonehead, he texted me or emailed me the other day and said, "Don't forget to wear your ham shirt." So I put it on, and he's not even wearing his.
That T-shirt doesn't mix
video
with
not coming
drinks
through, or what?
Yeah, you're coming through.
You can't see my video feed?
Nope, there's nothing. It's black.
What do you mean it's black? Seriously?
Yeah, it's black. All I hear is tappity tap.
All right, I have no idea.
I could hear a beeping in the background, like one of those heart lung machines.
Seriously, you haven't seen it at all? My video?
No, there's nothing. Can anyone else see it?
Something's going to self-destruct anytime.
No, I haven't seen any video from Eric at all tonight.
Really? Seriously?
Looks like your video's off.
Like, I want to know.
All right. Well, I had two. Before that pushy Floridian stepped on me, I have two questions for Hassan. One, the waveguide, the horns he did. What did you use for those? What were they made of?
They're made of cast metal, probably aluminum, and so I bought them as is. I originally thought I was going to buy.
And they were.
Yeah, sorry. Go ahead.
Sorry, no. Were they purpose built for as waveguides?
Yeah. So I originally tried to buy just the gun diode, and I'm like, oh, I can find a capacitor and a resistor, and I can machine some metal, and I'll just take some aluminum foil or something and make a waveguide. But then I told the guy what I wanted to do. He's like, I've got ready-made modules for sale. Just buy those, and they're already guaranteed to work. So I did, and I'm glad I did, because I have a lot of learning to do before I can just machine a waveguide like this with a cavity resonator. And it's, I've never done this before, so there's a lot of learning. In theory, you could build it yourself, but step by step, I guess. If you want to build a waveguide,
okay. And also, how?
Go ahead.
I'm just curious, how far apart have you been able to successfully have the sender and the receiver? I
think I took it 6-8 feet or something, and I didn't try to go very far in the room, because it was all I was holding it, staring at a voltmeter from far away, so I don't think I tried to go very far.
Right.
I just tried to prove it would work, but I think I have to properly kind of tighten up the connectors and stuff, and then it should work fine. If you want a waveguide, there's a very classic thing where somebody discovered that a Pringles can is exactly the right dimensions to make a waveguide for Wi-Fi signals. So they made the cantenna. You just take the output of a Wi-Fi router, ground one end to the case, and then the tiny center conductor just goes up and bends at an angle through the Pringles can. And I think there's aluminum foil on the inside, or there's already a metal lining, but it makes a really good Wi-Fi antenna.
Yeah, I've seen people use strainers, metal strainers as well, as a reflector for Wi-Fi. I've seen cantenas with Pringles cans. They use all kinds of different types of cans, right? And they do get some gain.
Yeah, that's right. Yeah, like 10 dB or something, and so they got some really good range off of it. Oh, about your question about the noise, Dave. Yeah, I did notice a lot of noise on this power supply. I used to use it to power up my ICOM 7300 because it does 30 amps, and it actually, I noticed that at 50 megahertz, 6 meters, there was noise all over the place. And then I switched to a car battery and it went away. And then I bought a linear power supply, and now there's absolutely no noise on it. But there is a ton of it. Actually, I think I hooked it up to the spectrum analyzer on my scope, and I noticed the same thing. There's high frequency noise up there.
Because it's a switching power supply, so you also have spurs at the frequency that it's switching at, and its harmonics. So yeah, there's a whole bunch of things. There's a bunch of videos for these switching power supplies, how to tame the noise. There's all kinds of videos on there how to do it, and it's relatively simple to cut back the noise quite substantially. You're always going to have noise, right? But you could cut it back substantially. The bottom line is those power supplies, you can't really use them for low noise purposes. Like I'm using it to test out airplane motors, so
right.
I don't care about noise.
Yeah, I'm discovering that too. I mean, for any kind of radio work, the noise levels are just humongous. So better to use batteries or linear supplies. Yeah.
Okay, so that was good. That was great, Hassan. Thanks. It's even though you couldn't demonstrate anything, it was a good conversation we had. I think there's a lot of interest there. Oh, there we go. Eric's got his shirt on. Eric's in the house.
Who goes to Antigua and takes a T-shirt like that?
Eric. And he's the only guy that'll go there and come back with junk. Eric, I'm so disappointed. You get a call sign from there, but you don't get a Canadian call sign. Like, really?
Coach Eric.
He's gone. He's offended.
That's a good point.
He's offended. Anyway, so maybe we could.
Don't.
Sorry, Peter.
I probably shouldn't comment, but don't think it wasn't talked about, Dave. What your reaction is going to be?
Yeah, he expected that. I think that's why he did that. You know, he expected to have those comments.
Okay.
Oh, that video is actually good, Eric. There, that's clear now.
Yeah, no, the internet is kind of spotty here, believe it or not. So anyway, if you can hear me, great. Did you hear that I went to an antique store yesterday? And I was sorely there was a CB radio there, and I was really tempted to pick it up, but I didn't. So be proud. Although I might sneak back there on Friday and tuck it in the suitcase where Sandy can't see it.
Yeah, Sandy's gonna beat you with a fish or something, a banana or a fig or something, a papaya or something.
No, she'll just get a big snapper and just beat the shit out of me.
Exactly. Anyway, there's a few good suggestions here for potential projects. I think. Michael, you mentioned the SDR. I don't think you were talking about it for a kit for us, but I jotted that down that that might be something, we might be interested in, some kind of a SDR receiver. Like ideally a transceiver would be good. Frank, you got your hand up?
Yeah. Just a minute. Well, there we go. I think the one he was talking about was the soft rock ensemble, and
Yes.
that the one?
I don't know. We never put it in boxes.
Yeah. Okay. Same thing.
Yeah, that looks familiar. Yeah.
Yeah. Yeah, I've built it, and it's a great little rig. I've never considered it for a build-a-thon, but that's good to hear that your club was successful with it. It would take a couple of sessions to build that one, but and it's probably, if you can still get it, it might be a bit pricey right now. Other than that, it's a good suggestion.
Yeah, I don't know whether you can still get them or not. I did look at the web page, and it looked like it wasn't there. And Daniel and I were kicking around the idea of maybe doing something, but I haven't investigated it at all. So it looks like maybe it's not available anymore. But I didn't bother to email anybody yet, so I don't know.
Yeah.
Didn't Giuliano have a SDR project that he was putting together, and he's using that Quisk software, which runs on a Raspberry Pi? It runs on Linux, and so he built it like to run on a Raspberry Pi, and he built the receiver himself. I vaguely remember him doing something with an SDR project way back when.
He did. He's got it on his website.
Now, that was, Frank, can you remember, was that a transceiver, or was it just a receiver?
I think it was a transceiver, but I'm not sure.
Yeah. So that might be something of interest. Anyone interested in a project like that? Dwayne?
Just speaking about SDRs, I just got a SDR receiver in the mail yesterday, and I plugged it in. It's under $20, covers 10 kilohertz to 1 gig. And the thing I like about it better than the dongles and stuff I've used, it's got 5 different amplifier inputs, and each one has got a bandpass filter for the proper frequency coverage. It's on AliExpress. I'll find the information and put it on the IO groups.
Yeah, that'll be great, Dwayne. And how much did you say that was?
Under $20.
Wow. Wow, that's a good. That might be a good kit. Is it comes built, or you have to build it yourself?
It comes built just like this, even got 5 SMA connectors for the 5 different frequency amplifier antenna inputs. Each of them you can kind of see there. Each one of them's got a bunch of surface mount stuff for bandpass filters for everything. Next thing I'm going to do is go and design a 3D printed case for it.
Yeah, that's pretty cool. We got a couple of hands up. I think Wayne had your hand up first.
Yeah, just to build on it, I'm pretty sure that the chipset used on the SDR that Dwayne just showed us is the same one used on the SDR Play, the one that I have it on. I was looking at it, in fact, on AliExpress. It looks like a pretty good deal. You have to, I guess the difference might be is that you have to have separate antenna connections or provide your own switches, because there's what is it, Dwayne, 5 different antenna inputs for the different frequency.
Yeah, there's five inputs. I mean, depending upon what you're looking at, one of them gives you 10 gig from 10 kilohertz up to 30 meg. Then there's Then there's like 30 to 60, then 60 to 100, 200, 200, and then like 400 to a gig, something like that. So it depends upon which band you're looking at. You probably only need one antenna, or if you got a couple of different antennas, different big frequencies you want to look at, then you can just bring it into each one of the antennas. It automatically switches inside.
Could you, because it's an antenna, could you use like pin diodes? Could you get the frequency response from a pin diode and use that as a switch? Use that to switch between the inputs there?
You could probably do it, but there's probably more involved making an antenna switch than there's in the SDR itself. When you get up switching high frequencies, you know, above above 20, 30 megahertz, it gets to be really hairy.
Mm-hmm.
Yep, that's why, because I think pin diodes are typically, I guess the affordable ones are probably good for HF. Frank, you had your hand up?
Yes, there's a question for Dwayne. Is that receive only, or is it transmitter or transceiver?
That's just a receiver.
Okay, that brings back memories, because we did have a couple of homebrew projects in the past. One was the Q4, and that was a multi-band with about 5 different bands on it, just a receiver. And it was based on the soft rock design in the early stages. And then later on, we came up with the Little Pup, which was another SDR receiver. So you're looking at homebrew projects. I mean, if you wanted to reinvent some of those or redo them in modern technology, that might be a possibility.
Yeah, just trying to search Pete Giuliano's website to find the SDR there, to see whether it was a receiver or a transmitter. But yeah, so that's a potential project. The other one is I think there was some interest in like a mag loop antenna for the receiver. We talked a little bit about potentially reverse engineering the antenna that Wayne has. So I don't know if anyone's interested in that.
Yes, I saw a video where someone described exactly how they made one, and it was pretty interesting. Or not very complicated, more mechanical than electrical.
Okay, and Frank, you got your hand up?
Yeah, I'd be interested in one that would transmit as well as receive, because of the limited restrictions that we have here for an antenna. So it'd be nice to put something like that up in the attic.
Yeah, and that what's the guy's name at? He's at Dayton all the time, and he was on a few talks. I think he's from South America, and he made a mag loop antenna, and he's now marketing it. Peter, go ahead.
Yeah, I think you're talking about the Alex loop.
Yeah, that's the guy. That's the
But
guy.
also, and then for a transmit though, loop, you're going to need a healthy capacitor.
Yeah, and then you're gonna have to figure out some way of tuning it. Otherwise, you have to manually go out and tune the capacitor. Because I've seen guys at Dayton where they've got tin cans. They've got tin cans inside of each other, and they've got a stepper motor, and they're moving it to vary the capacitance.
See, I don't mind going outside right at the moment to tune an antenna, but I don't think you guys would
No.
be. Oh, sorry, I didn't mean to rub that in. Oh, sorry.
Go ahead, Wayne.
Yeah, so I've been looking at mag loops for a while. There's a design that I do like. It uses a trombone capacitor. Do you know what that is? It's imagine you take the loop, extend the loop downwards at the bottom, and shove a piece of like a bent U-shaped piece of copper underneath of it, and you move that in and out, and that tunes your mag loop. So what people do is they take that part that moves up and down, and they strap a motor to it, and then they can tune it remotely if they choose to. But what's kind of cool about it from my perspective is you don't have to make it a copper pipe. The loop can be like plastic, and you wrap copper tape around the outside of it. And you wrap that tape down the loop too. So the only actual metal that you might need is the U-shaped inner side of the capacitor that slides in and out. So, it's I don't have too much metalworking skills, and I don't really want to try to bend a large piece of copper into a nice circle. You can use pretty much anything that like plastic pipe and more easily get that circle from it. And you can also use plastic parts to make the fittings for the trombone part of the capacitor. And
I've seen guys, as I said, Wayne, they use that at Dayton. I've seen guys where they've got tin cans, and they tin cans, and they just make
Inside
one
each other,
and the other, and it's exactly as you said. They have two of them, and yeah, as soon as you said trombone, yeah, it took me back, and that's what they would call it, is a trombone capacitor.
They look super easy to make, I think, from the way you put them together. But I haven't tried it, so can't vouch for that.
Okay, and Dwayne, you want to go ahead?
Yeah, the easiest one that I've seen, if you just want to play with them, Peter Parker, B3E, quite something on his YouTube channel. Years ago, he built a portable one for 40 meters. He just used coax for the loop. The outside shield and the ground are all tied together. And for a capacitor, he used 3 pieces of PCB material, and one just slides in between them to change the capacitance. So if you want something really easy to play with, hardly any mechanical building required, it's something to work. I built a loop that was good for QRP level, just out of some copper pipe, and I had a decent sized tuning capacitor that worked real well, and it was amazing. A little PVC stand sitting on the floor in my garage. I got decent contacts all over the States.
How would you tune it, Dwayne? Like I meant, like how would you know? How'd you get it tuned to be resonant on that frequency? Like, did you have to be transmitting and then look at the SWR and be moving the capacitor, or did you have some kind of automated mechanism for doing that?
The Q is real high, and once you get the thing set up to a resonant frequency, just tuning across the receiver, you hear a huge change in the noise level. It's just it's that selective. I mean, the bandwidth might be 20 kilohertz from not being able to hear anything to real good loud signals, and anywhere within that band, your SWR is pretty decent. I usually just stuck around one frequency and called like that after I had it tuned.
Oh, that's a good point. That's yeah, and I seem to remember when you mentioned that other people with mag loops say, yeah, you tune it based on receive to get the loudest noise coming in. Once you got the hiss at the loudest, then you're pretty close. And so the last thing I jot down here was, I don't know what to call it, Kevin. I called it an SDR protector. I don't know. I get what you were saying. It's like a clamp, so that once the signal comes in, it's too large, you would clamp it to a level that wouldn't damage your downstream receiver.
Yeah, I'm just Well, here I can show you the article, and then maybe that'll help explain it a bit. I'll close the chat, and let's see. And I want this. All right. So does everybody see that?
Yep.
Okay. So this is just I just scanned the pages out of the QST from whenever it was. I don't know. So the idea was August 2018. There you go. So the idea is that, you know, you have your transceiver and your antenna, but if you want to listen with, say, your SDR to give a, you know, a waterfall display or whatever on your big screen TV or whatever you have to check all the bands, you can just let this thing sit off the connected to the antenna, and it's got a gain control, and basically you won't blow up your SDR if you put this in the way. And so it's got just AC coupled into the circuit, couple of clamping diodes, and then a Cascode amplifier to provide some isolation, and it's also got a broadcast AM band filter at the front end here to reduce that. And then it's got, you know, some gain control stuff in here, and 50 ohms or so out to an SDR. So it's a pretty relatively simple circuit. And it's not really a transmit receive switch. That's what it says, but really all it is it's a high impedance amplifier that can take a beating. You know, they rate these diodes with the 1N4148s. They say you can handle 100 watts.
Yeah, but Kevin, one of the questions I always have about this, because whenever I connected anything up to my transmitter, and I'm transmitting any kind of power, you always get stuff bleeding across.
Yeah, well, I don't know that's what this guy was doing, and I was thinking, you know, I've always thought it would be nice on field day to have like a separate display that, you know, you can look and check the bands, or even the band you're in, whatever, or even just for display purposes, just, you know, something sitting there, and you can have a big screen TV with a waterfall, and if you're doing the Dakota station or whatever, it'd be cool to have something like that. But you don't want to burn up your receiver. And I just ran across this, and I thought, oh, that'd be interesting.
No, that is interesting, Kevin, because the waterfall idea, that's a great idea, to have a waterfall for our older radios, our older analog radios, right?
Yeah, and this guy, what he did, so he actually, I think you can actually buy the PC board or get the PC board layout off of ARRL, and he puts it in, because it's high impedance and all that, so he shields it inside a copper tube. And I don't know if there's a picture here. I thought there was a picture. Maybe not.
And there's, Kevin, there
it is. He had a vertical antenna, so he uses it as a small whip for a listening antenna, which you could also use for the diversity receive that you were talking about, Wayne.
Mm-hmm. Mm-hmm.
So anyway,
there was a company at the at Hamvention that they're every year. I think they're called FAR circuits, and they've got a lot of the boards from these ARRL articles.
Oh yeah, right. I've heard of them.
Yeah, and so maybe this year, if I'm down there, I could take a look and see if they've got these boards in stock, or even if we can get the Gerber files for them, we could get the boards made.
Yeah, I let my ARRL membership lapse, but it sounds like they have it available on the website. I don't know for what he says here.
So I think that's appealing. That's definitely an interesting project. I think, Al, you've got your hand up.
Yeah, just a couple things regarding fire circuits. I just ordered a couple of boards from them for that Wheatstone Bridge receiver, and they're quite inexpensive, fairly fast. I think it cost me about $6 for each board. I wouldn't say the boards were how would I say, it's a 25-year-old design, so it's a 25-year-old PC board technology. Maybe they've upgraded, but it's fully adequate. So it didn't have solder mass or a lot of the finer stuff we expect. On that SDR protection, I just wanted to share with you what I'm using. I've got a little box here from Array Solutions. Don't know whether that focused there, but this is specifically designed for protecting the front end of a receiver. I've got this on front of my SDR, primarily because I don't trust two-position coaxial antenna switches. And I was always afraid that if they didn't quite work, I could turn on my my amplifier and overload this thing. I just took the cover off, and it's probably very similar to the one that Kevin was just showing us. Is it going to focus? There it is. Fairly straightforward. Looks like there's a couple of an input and an output transformer, a couple of diodes and caps and trimmers. So you know, maybe we can get some inspiration from this type of device and roll our own. Maybe Kevin's device is something. I think I saw some active components in your circuit, Kevin, but something like this might be of some interest to people. Let's take this step one step further. I want to set my SDR up as a pan adapter. So this is probably the first step towards it. I haven't finished yet. But, maybe we should do a pan adapter project. I think it'll be quite useful.
Mhm.
Yeah, we could have it as a two-part process, right? Where we have to build the isolation device, the isolator. What's it called actually? What's that called?
Okay, so
Or switch or
it's called a receiver front end protector, RF limiter / arrestor, model AS-RXFEP, and it goes from 1 to 150 megahertz.
so I guess we could do something like a two-part project where we build maybe the SDR receiver first, and then we build the isolator to go at the front end. And you know, and I think Al, not Al here on the call, but the other Al who is out in Kitchener. What's Al's? It's Al, right? Eric that lives out in Kitchener that comes down to Dayton with us. It's Al and Ron, right?
Oh yeah, you're talking about Al Wolfrey?
Yeah, that's it. Al. Yeah, that Al. Yeah. So I know that Al was very keen on getting me some kind of a Raspberry Pi device to do like digital modes and do SDR and do everything. And I think that's what Pete Giuliano was getting at with his Quisk, a receiver, right?
Mm-hmm.
So so that sounds like it's something we could potentially, you know, talk about. Is that we have a two-part build? Go ahead, Peter.
Yeah, I was just going to ask Kevin, what was the issue of QST you were talking about?
Oh, geez, now I gotta go.
Just in case I get bored tomorrow sitting around, maybe I'll take a look and see if I can find the Gerbers down on
August
on the
2018.
March 28? March
No,
what?
August 2018.
Okay. And who's the author or the call sign?
And it is getting there here. KU6X.
Okay.
Okay.
If you find it, Peter, maybe you could post the link to it, or post the PDF.
Well, no, yeah.
Isn't there Staples near where you are?
Staples? Even if there was, I wouldn't go there. What, ruin my vacation?
Come on, you got to do some work. Yeah, my wife has a bunch of relatives in the Tampa area. Then you got Lakeland right there. They have Sun and Fun, which is probably coming up soon. That's where they have all the experimental aircraft.
All right.
They have a huge air show there. It's coming up. I think it's the next couple of months.
Well, actually, I was thinking I'm actually going to be heading up to on Sunday, so the wrong day, but just outside of Tampa here near Alcala. Frank, if you remember when we first started getting into SMT construction, we couldn't find at a reasonable cost low numbers for components. You could easily buy a roll of 1,000.1 capacitors, for example, at a penny a piece, but you couldn't buy, say, 10 or 20. But we found this place down in the States here in Florida, Night Fire Electronics or something along that line. Anyway, I was thinking of going up there and visiting that, but I'm not too sure if I will end up doing it. But they still sell the same stuff, and they sell what they call these engineering kits that are made up of all kinds of SMD components, active and passive and all that kind of stuff for a relatively reasonable price. But of course, today you can buy any kind of quantity of any size, cheap. But back when we first started, you couldn't, except for this place. Anyway.
Kevin, go ahead.
Yeah, I just I was just looking at the tail end of this thing that I scanned, and I realized that you guys have there's probably a couple of you be interested in this. So just give me I'm just going to share this for a second here. It's a protection circuit for your spectrum analyzer.
Oh, okay. I thought
inline spectrum analyzer station interface.
I thought you were going to say it's got an Arduino.
No, no, but for those of you who want to protect your spectrum analyzer, here's a circuit, and it's from 85X. He's a pretty good dude at ARL, I believe, and it's in the same issue, Peter. Page 34 in that same month. But it's for sampling RF and stuff, just to protect your SA from static and so forth and so on. So anyway,
and I guess Kevin, that'd be good for making relative measurements, right?
Yeah, I would think so. Yeah, it's anyway, it's just to give you some peace of mind from, like you said, high RF levels that are close proximity, static buildup, interface failure modes. I'm not sure what that means, other than you connect the wrong thing to the wrong place. I don't know. So anyway, I just saw that and I thought, oh, geez, that's kind of relevant.
Yep, I've blown up a couple of blown up some equipment here, and it was quite costly, but it turned out it was free. But it's just the good graces of Siglant, right? They were kind enough to repair my equipment. But never connect your SA up to a power amp without having proper attenuation. And even though you've got attenuation, you got to make sure it's isolated, because stuff will still bleed through.
Oh, wow.
But I think my problem is that if you read the documentation, it says be careful with harmonics, because you might think, okay, the fundamental is this, but once you add the energy from the harmonics, it could add up, and it could be strong enough where it could blow your front end of your SA. So I think that's how I blew mine, is through using like measuring square waves and doing stuff like that, because that's got it's got quite a lot of harmonics, and it's not a insignificant amount of energy that the harmonics have, right?
Yeah. So out of the three of you that have SAs, two of you have had problems with them.
But I think Michael, your problem, did you ever figure out did they ever tell you what the issue was with yours?
Oh.
Michael, did you got your? I take it you got your SA back. Did you ever get a description of what the issue was that caused your SA to fail? I don't know if Michael's still with us. You're
Oh.
you're on mute, Mike.
Maybe he left for a minute. But yeah, it just seems you have to be very cautious with these things.
I'm giving essay lessons at any time when I get back.
Okay, any other comments? Anyone have anything to add, to say? Any other projects you think that would be cool that we could add to the list?
You talk. What about building upon the DCR once we get the DCR done? For example, audio circuits on the tail end of it. And I think Ken is working on something on it as well as an add-on, but I can't remember what it was off the top of my head. Maybe some other ideas. I know at one time when we first started talking about the DCR, we thought maybe a project after that would be a follow-up project, I should say, would be like either doing a regen or a superhet. And then, of course, there's always maybe some kind of a simple transmitter.
Yeah, as long as we get to use an FPGA, then we're good.
Yeah.
Go ahead, you Antiguan guy, you. You're on mute. Your mic's not working. We can't hear you. I think he's doing that on purpose.
Kick him out.
How about this? Can you hear me?
Yeah, now we can.
Okay. Who knows? Don't know why it's not working. Anyway, I just wanted to plus one Frank's comment about revitalizing some of the initial homebrew things from 20 years ago, 25 years ago, whatever it was, right? Modernizing and, upgrading with new technology. So I thought that was a great idea.
Yeah, that's the nice thing about PARC. PARC has got a rich history, or the homebrew group has got a rich history of doing all kinds of projects. And Frank has got most of them in a nice little cabinet. Do you still have that cabinet, Frank?
I have, since I moved, the cabinet sort of didn't come with me, but what I have now is a library table, and I have spread every one of the projects out with the manual underneath it. So we have the manual and the sample of the project from all the projects, excepting the ones that I use daily. They're on my workbench here on my ham shack, but I have those downstairs, and they're all laid out. I don't know. I didn't know what to do with them. I didn't want to put them in a box, so I displayed them. And there they are.
If you
Post
get
the picture.
Frank, I was just about to say that, Peter, is if you get a chance, Frank, maybe take a picture of it and post it for us.
Okay, we'll give it a go.
And I think Al's got his hand up.
Yeah. Just one thought. We've been doing buildathons, or Frank and the group have been doing buildathons. What are we up to? About 26 or 27?
To 25.
25. Okay. I guess when you're trying to decide what to build, we need to look at our audience and ask, well, do we have any new members, younger members that we could repeat things? Or have we basically made many things for many people? I'm wondering whether we should throw a question out to the general buildathon population in PARC and see what maybe they want. The other thought is, would we ever want to consider maybe say, alternating from a basic buildathon for everybody to a specialized buildathon for perhaps the group we're talking to right now, something a little more elaborate or perhaps a little more expensive. It's getting progressively difficult to be everything for everybody, and but maybe we should throw it out to the park membership and ask them what would they like to see on a build-a-thon. Just a thought.
That's an excellent point, Al, because we did have a similar conversation way back when, and that's where Peter's comment was about the DCR, because we originally talked about building that DCR for our newer members. So, because we had a number of newer members who had never built a radio before, and we thought, okay, here's a simple way to build a radio, and then on top of that, we could add on modules. Maybe the next radio would be a superhead, and that way you learn about what a direct conversion receiver is, then you learn what a superhead is, and so we would walk our newer members through. But you're absolutely right. If you look at the audience now, I don't think there's anyone on this audience that we have here, just looking through, who I would call a novice when it comes to radio. So very good point, Al, that maybe we should take a look at something a little bit more complex, maybe even a little bit more expensive if people have the appetite to spend a little bit more and build something that, or get something which will be of a bigger benefit to us, given where we are in the hobby. Very good point.
Yeah. No, don't get me wrong. When we do something more basic for the newer people, I'm totally on board, because sharing this hobby is what it's all about. So I enjoy doing that as well. But yeah, I think we just need to analyze our audience and try to cater to whoever's going to be participating.
And I think that's why, I'm kind of interested in the whole waterfall, getting a pan adapter connected up where you've got a separate isolator. That's something that appeals to me, at least. Mm-hmm. I don't know if it appeals to everyone else. It sounds like it does.
Look that up to the DCR?
Yeah. Yeah, the DCR, I don't think it's going to cut it with a good pan adapter.
Well, Ken is already working on something along those lines. I was just, as soon as you mentioned that, I just remembered that, working on an output on the DCR. So when you attach something to it, it does not swing the frequency.
Yeah, it's the thing though, is if you put any kind of spectrum on the DCR, it's only audio. You're looking at like 6 kilohertz or something like that. Whereas with a SDR, you're potentially looking at the entire band, right?
It's Michael here. I have to go. Sorry.
Okay, Michael. 7-3, thanks for joining us.
Yeah, talk to you later.
Okay, take care. Yeah, I just noticed on Jitsi it says add a breakout room.
That was something they added a couple of months ago or so. What I've noticed is that they've seems to have reinstituted the 60-minute limit on recordings, so they need to be spliced together. That was gone for a year or so. So now it's back to 60 minutes, and the recording shuts off automatically.
Yeah, I noticed too, Eric. If you're recording, I can't record.
Oh, okay. Yeah, you can't press the record button once I've started it.
Yeah, and it makes sense because it's a bandwidth issue. It's server cycles, because we're using their server, and for them to stream multiple recordings to the same session doesn't make sense.
Right.
So I think it makes sense what they're doing. They're limiting one recording. So anyone else have any comments? Any suggestions? Anything to say? Or should we wrap this puppy up?
I say it's 10:25 here in Atlantic Standard Time. I'm tired. I have to be up at 5 in the morning to catch a ferry to Barbuda. Boo-hoo.
Like I care.
Feel for me. Come on.
Like I said, like I care.
Okay, you can all come down as long as you guys can make it here by 5 a.m.
Yeah, no worries. Yeah, that's gonna happen.
I'll pay for your trip, your ferry trip.
How about airfare?
Okay, 73 to all.
Bye-bye.
Okay,
Yep.
guys. Good night.
Next time around.
Thanks for
Thanks,
joining. Take care.
Yep.
7-3. Catch
All
you
right.
on the flip flop.
Okay, great meeting, guys.
Thanks.
Bye.
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 See y'all in a couple weeks.
Yeah.